The red phone on Stanislav Petrov's console lit up at 12:14 a.m. Moscow time on September 26, 1983. The computer system at Serpukhov 15, the Soviet Union's early warning bunker south of Moscow, had detected 5 American ICBMs launching from Montana. Petrov had exactly 12 minutes to decide whether to recommend a retaliatory nuclear strike that would kill 200 million people. He stared at the screen, his hand hovering over the alert button that would wake General Secretary Yuri Andropov and initiate Soviet launch protocols. The satellite data looked legitimate. The system's confidence level read 100%. But something felt wrong. Petrov made his choice. He reported the alarm as a computer malfunction. He was right. Sunlight reflecting off high-altitude clouds had fooled the satellites. His decision prevented World War III. When Soviet officials investigated the incident weeks later, they quietly reassigned Petrov. Rather than celebrate him, the Cold War ran on secrecy, and admitting their early warning system had nearly caused Armageddon wasn't acceptable. They buried the incident in classified files. 4,000 miles west, a 73-year-old man named Meredith Gardner read about the false alarm in the Washington Post with particular interest. Gardner had spent his career in a windowless office at Arlington Hall Station, the former girls' school that housed American code-breaking operations. While Petrov had 12 minutes to prevent catastrophe, Gardner had spent 12 years doing something equally important: cracking the encryption system that Soviet intelligence used to communicate with their spies in America. Gardner's work remained so classified that even in 1983, almost nobody knew his name. The cables he decrypted in the 1940s had exposed Soviet atomic espionage, identified British intelligence officers working for Moscow, and revealed the scope of Stalin's spy networks inside the Manhattan Project. His breakthroughs gave Western intelligence the tools to understand Soviet operations during the most dangerous decades of the Cold War. The information Gardner extracted from encrypted Soviet telegrams helped American and British officials make calculated decisions rather than panicked guesses about Soviet capabilities and intentions. Petrov's 12-minute decision got attention because it was dramatic, a lone officer defying his instruments. Gardner's 12-year achievement remained invisible because cryptography works best when your adversary doesn't know you've broken their codes. While Petrov gambled on intuition, Gardner had built certainty through mathematics. His decryptions provided the intelligence foundation that helped prevent the kind of miscalculation that nearly happened at Serpukhov 15. The two men never met. Petrov died in 2017, finally receiving recognition for his choice. Gardner had passed away in 2002, his obituaries carefully vague about his career. But their work connected across decades of Cold War tension. Gardner's patient cryptanalysis in the 1940s and 1950s created the intelligence clarity that made measured responses possible in later crises. When Petrov decided not to launch, he was operating in a world where decades of signals intelligence, starting with Gardner's breakthroughs, had given both sides enough information to recognize false alarms. This is the story of how a linguist from Okmulgee, Oklahoma, cracked the most secure encryption system ever devised, exposed Soviet intelligence operations that reached into the Manhattan Project, and helped establish the cryptanalytic methods that protected the West during 40 years of nuclear standoff. Meredith Knox Gardner grew up speaking only English in Okmulgee, a railroad town in eastern Oklahoma where his father worked as a teacher. By age 19, he taught himself German, French, Spanish, Italian, and Sanskrit. He enrolled at the University of Texas in 1935 to study philology, the science of how languages evolve, and discovered he possessed an unusual neural wiring for pattern recognition. While other students memorized vocabulary lists, Gardner saw the mathematical relationships between verb conjugations, the structural logic of grammar systems, the statistical frequencies of letter combinations. He earned his master's degree in German literature in 1938, then moved to the University of Wisconsin for doctoral work. His dissertation focused on Old High German syntax, examining how sentence structures shifted between the 8th and 11th centuries. The work required comparing thousands of manuscript fragments, identifying patterns in how scribes chose word order, detecting when later copyists had modified original texts. Gardner spent months in the university library with handwritten note cards, building frequency tables of grammatical constructions, calculating probabilities of word placement. He was training for cryptanalysis without knowing it. In 1940, Gardner took a teaching position at the University of Akron in Ohio, instructing undergraduates in German grammar at $2,200 per year. He was 26 years old, newly married to a woman named Belle, planning an academic career analyzing medieval texts. Then came Pearl Harbor. The Army Signal Intelligence Service sent recruiters to universities across America, looking for people with specific talents: mathematicians who understood statistics, linguists who could parse unfamiliar languages, anyone who had experience finding patterns in corrupted or incomplete data. Gardner received a letter in March 1942. The Signal Intelligence Service wanted language instructors who could teach Japanese to intelligence officers headed for the Pacific Theater. Gardner spoke no Japanese, but his recommendation letters emphasized his facility with language acquisition and his methodical approach to grammatical analysis. He reported to Arlington Hall Station in Virginia, a 3-story brick building that had been a private girls' school until the Army requisitioned it for code-breaking work. They started him teaching Japanese. Gardner learned the language in 6 weeks, then spent 8 months instructing military officers in basic conversation and written characters. But his supervisors noticed he kept suggesting improvements to their cryptanalytic techniques, ways to identify linguistic patterns in intercepted Japanese military communications, methods for distinguishing dialects in radio traffic. In December 1942, they transferred him to the Russian section. The section occupied 2 rooms on Arlington Hall's 2nd floor. 4 analysts worked there, processing intercepted Soviet diplomatic and trade cables. The work seemed straightforward. The Soviets were American allies, and the cables mostly contained routine trade negotiations and embassy coordination. But in early 1943, the Army began noticing something odd. Certain Soviet cables used a different encryption system than their diplomatic traffic. The messages came from Soviet offices in New York, San Francisco, and Washington, but they weren't going to Moscow's foreign ministry. They were addressed to the NKVD, Soviet intelligence. Gardner's supervisor handed him a stack of encrypted telegrams. The messages looked like random 5-digit number groups, hundreds of them per cable, seemingly perfect gibberish. "They're using one-time pads," the supervisor explained. "Theoretically unbreakable. See what you can do." Gardner took the cables back to his desk, a wooden table next to a window overlooking Arlington Hall's tennis courts. He had no idea he was looking at the most secure encryption system human beings had ever devised, and he definitely didn't know he was about to spend the next 4 years breaking it. One-time pad encryption was mathematically perfect. Soviet cryptographers had proven it in the 1920s. If you used a truly random key exactly once, the encrypted message became absolutely unbreakable. The system worked like this. Moscow gave each intelligence officer a pad containing pages of random 5-digit numbers. To send a message, the officer converted words into numbers using a codebook, then added the random key numbers from the pad using modular arithmetic. The result looked like meaningless digits. The recipient in Moscow had an identical pad and simply subtracted the key numbers to recover the original message. The beauty of the system was its immunity to frequency analysis, the technique and that had broken every other cipher in history. Normally, cryptanalysts could exploit the fact that certain letters appeared more often than others in natural language. The letter E appears in 13% of English text, while Z shows up less than 1% of the time. But one-time pad encryption destroyed those patterns. Even if the plaintext message contained a dozen E's, each one got encrypted with a different random number, producing completely different ciphertext digits. No patterns existed to analyze. The Soviet system had additional layers of protection. They used two-stage encryption, first converting Russian words into 4-digit code groups using a 25,000-entry codebook, then adding the one-time pad numbers. Even if Gardner somehow recovered the code groups, he'd still need to crack the codebook to read the actual Russian text. And the Soviets rotated their codebooks every few months, changing the number assigned to each word. Gardner received 2,900 intercepted cables from the Venona project, the Army's code name for the Soviet intercept operation. American listening posts had been recording Soviet telegraph traffic since 1939, first from a station on the roof of the Federal Communications Commission building in Washington, later from facilities in California and Virginia. The cables sat in storage because nobody thought they could be decrypted. Gardner's assignment was essentially academic: study the encryption structure, write a technical report, confirm what cryptographers already knew. One-time pads were unbreakable. He started by creating frequency tables, even though frequency analysis shouldn't work. Gardner counted how often each 5-digit group appeared across all 2,900 messages. He built charts showing which groups appeared at the beginning of messages versus the middle versus the end. He calculated the probability distributions of first digits, second digits, third digits. Everything should have been random. Everything should have produced flat, meaningless distributions. But they didn't. Certain 5-digit groups appeared slightly more often than pure randomness predicted. The variation was tiny, maybe 3% deviation from expected frequency. But Gardner's statistical training from his dissertation work let him recognize it. Something was wrong with the Soviet one-time pads. Gardner spent 6 months in 1944 building bigger frequency tables, processing every intercepted cable through his statistical filters. He requisitioned 3 clerks from the Army typing pool to help tabulate digit frequencies by hand. They filled dozens of ledger books with tallies. By December 1944, Gardner had identified approximately 10,000 5-digit groups that appeared more frequently than random chance predicted. He couldn't read them yet. He had no idea what Russian words they represented. But he knew the Soviet one-time pads weren't truly random. The math suggested something impossible. Moscow had reused portions of their one-time pads. Somewhere in Soviet intelligence headquarters, a code clerk had made copies of pad pages and distributed identical, random numbers to multiple intelligence officers. The pads were supposed to be burned after use. Someone had screwed up. Gardner now had a theoretical weakness to exploit. He still had no method for actually breaking the encryption. That would take another 2 years. Gardner's breakthrough came on a Thursday afternoon in August 1946. He was analyzing a cable sent from New York to Moscow on December 13, 1944, message number 1699 in the Venona collection. The cable contained 278 5-digit groups. Gardner had already identified that portions of this message shared one-time pad sequences with 3 other cables from different dates. That meant he could use the reused pad sections like a key, comparing how the same random numbers encrypted different plaintext messages. The technique was called depth analysis. If 2 messages used the same one-time pad numbers, Gardner could subtract one encrypted message from the other, eliminating the random key and leaving only the relationship between the 2 underlying plaintext code groups. It didn't reveal the actual words, but it revealed structure. Gardner worked through the subtraction by hand, using a mechanical calculator to process the modular arithmetic. After 4 hours, he had isolated a sequence that appeared in all 4 messages at roughly the same position. The pattern suggested a repeated word, something that appeared frequently in Soviet intelligence cables. Gardner made a guess. The most common word in any intelligence communication is information. He looked up information in a captured Soviet codebook from 1943, a diplomatic code the Soviets had abandoned, but that shared structural similarities with their intelligence codes. The codebook gave information, the code number 8748. Gardner tried subtracting 8748 from the mysterious repeated sequence in message 16-9. The result was 3945. If Gardner's guess was correct, 3945 was a one-time pad number that a Soviet code clerk had mistakenly used multiple times. He could now use 3945 to decrypt other code groups in messages that shared this pad sequence. Gardner worked backward through message 1699, subtracting 3945 from adjacent encrypted groups, trying different Russian words from the old codebook, seeing if the results made linguistic sense. 3 hours later, Gardner had recovered 17 code groups from message 1699. The partial plaintext read, "Information on unknown word, uranium, unknown word, for the unknown word of atomic bomb, unknown word, transferred by unknown word to unknown word, contact." Gardner's hands shook as he typed up the decrypt. Message 1699 was about atomic espionage. Someone in New York had sent information about the Manhattan Project to Moscow in December 1944, 6 months before the Trinity test in New Mexico, 8 months before Hiroshima. The cable proved Soviet intelligence had penetrated America's atomic weapons program. Gardner took his decrypt to his supervisor, Lieutenant Colonel Frank Rowlett, who had broken Japanese diplomatic codes before Pearl Harbor. Rowlett read the partial plaintext 3 times, then walked Gardner directly to the office of Colonel Carter Clark, Chief of the Army's Special Branch. Clark looked at the decrypt and picked up his phone. Within 2 hours, Gardner was briefing FBI counterintelligence agents on his methodology. The FBI had suspected Soviet atomic espionage since 1943, but they had no evidence and no names. Gardner's decrypt proved the operation existed. Now the race was on to identify the spies before they could pass information about America's hydrogen bomb program, which was just beginning. Gardner went back to his frequency tables with new urgency. He had 2,900 cables to decrypt, and somewhere in those messages were the names of Soviet agents working inside Los Alamos, Oak Ridge, and the University of Chicago's Metallurgical Laboratory. Gardner spent the next 6 months attacking message 1699's companion cables, the other messages that shared reused pad sequences. By February 1947, he had recovered enough code groups to identify the spy's codename. The Soviets called him Rest. His real name would take another 2 years to discover. The breakthrough that revealed Rest came in December 1948, when British intelligence shared a captured Soviet codebook recovered from a trade mission in Finland. The codebook gave Gardner 35,000 verified code, group-to-word translations, vastly expanding his ability to decrypt Venona messages. He returned to message 1699 and its related cables with this new tool. Within 3 weeks, Gardner had extracted enough technical detail to reconstruct what Rest had given the Soviets. The spy had provided the exact measurements of the uranium tamper in the plutonium bomb design. A 4.5-inch thick sphere of uranium-238 that reflected neutrons back into the fission core, increasing the bomb's efficiency. He'd given Moscow the precise method for fabricating polonium-beryllium initiators, the neutron sources that triggered the chain reaction. Most damaging, he'd transmitted the theoretical calculations for how much fissionable material was needed for a self-sustaining explosion. This wasn't preliminary research. Rest had access to the final bomb specifications. The FBI began cross-referencing every scientist who had worked at Los Alamos against the technical details in Gardner's decrypts. Rest clearly understood advanced nuclear physics and had access to weapon design documents, which limited the suspect pool to about 40 physicists with high-level clearances. But Gardner found something else in the cables: travel dates. One message mentioned Rest would be in Santa Fe on February 3, 1945, returning to his camp in mountains. The language was odd. Soviet agents didn't normally describe Los Alamos as a camp. Gardner consulted with FBI agents familiar with the Manhattan Project's security arrangements. Los Alamos scientists weren't allowed to leave the facility without authorization, and their travel required documented approval. The FBI pulled travel records for early February 1945. Only 3 Los Alamos physicists had received passes to visit Santa Fe on February 3rd. One was Robert Oppenheimer. The second was Edward Teller. The third was Klaus Fuchs. Fuchs was a German-born physicist who had fled the Nazis in 1933, completed his doctorate at the University of Edinburgh, and joined the British Atomic Research Team in 1941. When Britain shared its nuclear research with America in 1943, Fuchs came to New York as part of the British mission to the Manhattan Project. He transferred to Los Alamos in August 1944, working directly on implosion lens design for the plutonium bomb. His security clearance was impeccable. He'd been vetted by British intelligence. Gardner found 16 more Venona cables mentioning rest between 1944 and 1945. The messages contained technical details that matched Fuchs's specific areas of expertise: hydrodynamic compression, equation of state calculations for plutonium under extreme pressure, the optimal geometry for explosive lenses. The FBI shared Gardner's decrypts with British intelligence in October 1949. MI5 arrested Fuchs at his apartment in Harwell, England on February 2, 1950. Fuchs confessed within a week. He'd been recruited by Soviet intelligence in 1941 and had been passing atomic secrets to his handler, a Soviet agent named Harry Gold, since 1942. His information had accelerated the Soviet atomic bomb program by at least 2 years, when the Soviets detonated their first atomic weapon on August 29, 1949, shocking American intelligence analysts who had predicted 1952 at the earliest. They used an implosion design nearly identical to the Fat Man bomb dropped on Nagasaki. Fuchs had given them the blueprints, but Gardner wasn't finished. Gold's name appeared in other Venona messages, connected to different agents. One cable from June 1945 mentioned Gold meeting with Antenna and Liberal in New York. Gardner started decrypting those messages. Within 6 months, he'd identified Julius and Ethel Rosenberg as the coordinators of a separate espionage ring that had recruited American engineers working at Los Alamos. The investigation would eventually expose 14 Soviet agents. Gardner found the British connection in March 1951 while decrypting a cable sent from New York to Moscow on September 21, 1944. The message referenced Homer, a Soviet agent working inside the British Foreign Office who had provided information about American diplomatic negotiations during the Tehran Conference. The decrypt contained a specific detail. Homer had recently been posted to Washington as first secretary at the British Embassy. Gardner cross-referenced the timing. In September 1944, only one British diplomat had recently transferred to Washington in that position, Donald Maclean. Maclean was Cambridge-educated, son of a prominent liberal politician, recruited into the Foreign Service in 1935 at age 22. His posting to Washington gave him access to classified Anglo-American cables about atomic policy, military strategy, and diplomatic coordination. The Venona decrypts revealed he'd been passing copies of these cables to Soviet intelligence since his arrival. But there was something else in the messages, references to Homer receiving instructions from another agent, someone the Soviets codenamed Stanley. Gardner spent 2 months attacking cables that mentioned Stanley, trying to extract enough context to identify him. A July 1945 message contained the critical detail. Stanley had recently been appointed head of Section 9 in British intelligence, the counterintelligence division responsible for monitoring Soviet operations. The appointment had happened in early 1945. Gardner didn't have access to British intelligence personnel files, but the FBI did. They contacted MI6 with a simple question. Who took over Section 9 in 1945? The answer came back immediately. Harold Adrian Russell Philby. Everyone called him Kim. Kim Philby was MI6 aristocracy. His father, St. John Philby, was a famous Arabist and explorer. Kim had been recruited into British intelligence in 1940, worked with Special Operations Executive during the war, then transferred to MI6's counterintelligence division. His appointment to head Section Numlin put him in charge of Britain's entire anti-Soviet intelligence apparatus. He was responsible for identifying Soviet spies, and according to Gardner's decrypts, he'd been working for Moscow since 1934. The implications were catastrophic. Philby had access to British and American operations against Soviet intelligence. Every attempt to recruit Soviet officers, every surveillance operation, every defector interview, Philby knew about them and could warn Moscow. The Venona decrypts revealed he'd compromised at least 50 operations between 1945 and 1951, including the Albanian resistance operation that had gotten 300 guerrillas killed when Soviet armed Albanian security forces ambushed them. The FBI shared Gardner's decrypts with MI6 in May 1951. British intelligence pulled Philby's operational files and found the confirmations, meetings on dates that matched the Venona cables, access to information that appeared in Soviet messages days later. But MI6 had a problem. Gardner's decrypts couldn't be used in court without revealing that America had broken Soviet codes. If they arrested Philby based on Venona evidence, Moscow would know their encryption was compromised and would change systems. All of Gardner's work, all the counterintelligence value of reading Soviet cables, would evaporate. MI6 decided to confront Philby quietly, hoping he'd confess or defect. They summoned him to London from his post in Washington and conducted 9 days of interrogations. Philby denied everything. Without usable evidence, MI6 couldn't prosecute. They forced his resignation from the intelligence service in July 1951, but couldn't arrest him. Philby spent the next 12 years in Beirut, working as a journalist before finally defecting to Moscow in 1963. Gardner's decrypts eventually exposed 3 more members of the Cambridge spy ring: Guy Burgess, Anthony Blunt, and John Cairncross. All had been recruited by Soviet intelligence in the 1930s and had risen to positions inside British government and intelligence services. The 5 men had compromised Western intelligence operations for nearly 2 decades. Gardner's techniques revolutionized Western counterintelligence in ways that extended far beyond identifying individual spies. Before Venona, American and British intelligence services operated largely blind against Soviet operations. They knew Moscow ran espionage networks, but they had no systematic way to map those networks or understand their structure. Gardner's decrypts provided the first comprehensive view of how Soviet intelligence actually functioned. The cables revealed that the NKVD operated 3 separate intelligence networks in the United States during the 1940s. One focused on atomic espionage, coordinated by agents like Julius Rosenberg and Harry Gold. A second targeted political intelligence, recruiting sources inside the State Department and Treasury. A third specialized in technical intelligence, stealing industrial designs and military technology. The networks didn't communicate with each other. Compartmentalization that Moscow enforced to prevent a single arrest from compromising multiple operations. Gardner's work showed Western intelligence services what to look for. His decrypts identified the behavioral patterns of Soviet intelligence officers, their communication schedules, their preference for meeting agents on the last Thursday of each month, their use of specific recognition phrases. The FBI began training counterintelligence agents using Gardner's decrypted cables as case studies, teaching them how Soviet handlers recruited sources, how they structured dead drops, how they exfiltrated information. The techniques Gardner uncovered in Venona messages became the foundation for American counterintelligence doctrine throughout the 1950s. More importantly, Gardner developed cryptanalytic methods that transformed signals intelligence. His statistical approach to breaking one-time pads, looking for tiny deviations from randomness, building massive frequency databases, using linguistic patterns to verify mathematical hunches, became standard practice at the newly formed National Security Agency. When NSA established its Soviet Cryptanalysis Division in 1952, they based the entire operation on Gardner's Venona methodology. Gardner himself stayed at Arlington Hall, working in the same second-floor office, attacking increasingly difficult encryption systems. After completing the Venona project in 1952, he'd eventually decrypted portions of 2,200 of the 2,900 cables. He shifted to North Korean and Chinese communications during the Korean War. His techniques proved adaptable. Chinese military encryption used different mathematical systems than Soviet codes, but Gardner's statistical methods still found the patterns. His decrypts revealed Chinese troop movements ahead of their massive November 1950 intervention, giving American commanders 3 days' warning before 300,000 Chinese soldiers crossed the Yalu River. The impact of Gardner's work compounded over decades. Intelligence services began recruiting linguists with statistical training, building on Gardner's model of combining language expertise with mathematical analysis. The CIA established a cryptanalysis training program in 1955 that taught Gardner's frequency analysis methods to new analysts. When the Soviets introduced machine encryption in the late 1950s, using electrical rotor systems instead of paper one-time pads, American cryptanalysts applied Gardner's principles to the new systems, looking for the tiny statistical anomalies that revealed mechanical patterns. By 1960, Gardner had trained 37 cryptanalysts who went on to lead Soviet and Chinese analysis sections across American intelligence agencies. His former students cracked Vietnamese communications during the 1960s, analyzed Soviet missile telemetry during the 1970s, and developed the computer-based cryptanalysis systems that NSA used during the 1980s. The field of modern signals intelligence traces directly back to techniques Gardner developed while attacking those 2,900 Venona cables. But none of this was public. Gardner's name never appeared in newspapers. His colleagues at Arlington Hall knew him as the quiet linguist who walked to work from his apartment 3 blocks away, ate lunch at his desk, and left precisely at 5 p.m. every evening. He published no papers, gave no lectures, received no awards. The Venona project remained classified top secret, locked in NSA vaults, where even most intelligence officials couldn't access it. Gardner retired from NSA in 1972 at age 58, completing 30 years in signals intelligence without ever discussing his work with anyone outside the classified community. His colleagues threw him a small party in a conference room at Arlington Hall. They gave him a plaque thanking him for distinguished service to the nation. The citation didn't mention cryptography, Soviet codes, or the Venona project. His wife Belle, who had lived with him through 3 decades of his career, had no detailed knowledge of what he'd actually done. Gardner told her he'd worked on translation projects. He moved to Chevy Chase, Maryland, and spent retirement reading medieval German literature, the subject of his abandoned doctoral dissertation from 1942. He joined the Linguistic Society of America and attended their annual conferences, presenting papers on Old High German syntax evolution. Other linguists who met him at conferences assumed he'd spent his career as a government translator. Gardner never corrected them. The secrecy agreements he'd signed when joining the Signal Intelligence Service in 1942 remained in effect for life. The Venona project itself stayed locked away. When Julius and Ethel Rosenberg were executed in 1953 for atomic espionage, the prosecution couldn't mention Gardner's decrypts at trial. Using the cables would have revealed American capabilities against Soviet codes. The Rosenbergs' defenders spent decades arguing the case was built on fabricated evidence. Gardner's decrypts, which proved Julius Rosenberg had coordinated a spy ring, sat in NSA vaults, unavailable to historians or journalists. When Kim Philby published his memoir in 1968, describing his career as a Soviet agent inside British intelligence, he made no mention of how he'd been discovered. Western intelligence services couldn't publicly acknowledge that American cryptanalysts had read Soviet cables identifying Philby, so his exposure remained mysterious. Philby spent the rest of his life in Moscow, claiming he'd voluntarily defected rather than being caught. The Cold War's nuclear standoffs, the Cuban Missile Crisis in 1962, the Able Archer war scare, In 1983, the entire 40-year confrontation between NATO and the Warsaw Pact played out in a world shaped by Gardner's cryptanalytic breakthroughs. The intelligence clarity that Western leaders gained from reading Soviet communications in the 1940s and 1950s established baseline knowledge about Soviet capabilities and intentions. That foundation prevented the kind of catastrophic miscalculation that could have turned the Cold War hot. But nobody knew Gardner's role. Not historians, not journalists, not even most intelligence officials. The Venona decrypts were so sensitive that NSA restricted access to fewer than 30 people at any given time. When the Soviet Union collapsed in 1991, American intelligence agencies began declassifying Cold War materials. The Venona project stayed classified. Finally, in July 1995, NSA released the first batch of Venona decrypts to the public, 2,900 cables, that Gardner and his team had worked on between 1943 and 1952. The release included Gardner's original decryption notes, showing his handwritten annotations, his statistical calculations, his linguistic analysis. Historians suddenly had documentary proof of Soviet espionage operations that had been debated for 5 decades. The Rosenberg case, the Hiss case, the Cambridge spy ring, all of it confirmed by Gardner's decrypts. Gardner was 81 years old when Venona was declassified. He gave exactly one interview to a CIA historian, a brief recorded conversation in his Chevy Chase living room where he explained his frequency analysis techniques and described his breakthrough on message 1699 in August 1946. The interview lasted 40 minutes. Gardner didn't consider his work particularly dramatic. He'd simply applied linguistic training and statistical methods to an encryption problem. He seemed puzzled that anyone found it remarkable. He died on August 9, 2002, at age 88. His obituary in the Washington Post ran 4 paragraphs and identified him as a retired government linguist. The full scope of Gardner's achievement only became clear after his death, when historians gained access to declassified NSA records and could reconstruct how his work influenced Cold War intelligence operations. The 2,200 Venona messages he decrypted represented just 3% of total Soviet intelligence traffic during the 1940s. But that 3% exposed the architecture of Soviet espionage in ways that shaped Western counterintelligence for 40 years. Gardner's decrypts identified 349 Americans who had covert relationships with Soviet intelligence between 1942 and 1945. Most were never prosecuted. Using the decrypts as evidence would have compromised sources and methods. But FBI counterintelligence used the information to map Soviet networks, identify recruitment patterns, and understand Moscow's intelligence priorities. When new Soviet agents appeared in the 1950s and 1960s, American investigators recognized the behavioral signatures because Gardner's decrypts had revealed how the system worked. The intelligence services of 7 NATO countries built their Cold War counterintelligence operations on foundations that Gardner established. British MI5 restructured its Soviet section based on network patterns visible in Venona cables. Canadian intelligence used Gardner's decrypts to identify the GRU spy ring that Igor Guzenko exposed in 1945. Australian counterintelligence traced Soviet penetration of their atomic research program using techniques Gardner had developed for analyzing communication patterns. Gardner's work prevented strategic miscalculation during the Cold War's most dangerous moments. When Soviet Premier Nikita Khrushchev installed nuclear missiles in Cuba in October 1962, American intelligence services had 20 years of experience reading Soviet intentions based on patterns first identified in Venona traffic. President Kennedy's advisors could distinguish between Soviet bluffing and genuine threats because they understood Moscow's operational doctrine, understanding built on intelligence foundations that Gardner had established 2 decades earlier. The 1983 Able Archer incident, when NATO military exercises nearly triggered Soviet nuclear launch protocols, didn't escalate, partly because Western intelligence had spent 40 years developing sophisticated models of Soviet decision-making. The clarity came from signals intelligence traditions that traced directly to Gardner's methodologies. His patient statistical analysis in the 1940s created the cryptanalytic culture that protected both sides from catastrophic misunderstanding. Modern cryptography exists in Gardner's shadow. When NSA recruits new analysts, they study his Venona work as foundational text, how he recognized patterns in noise, how he used linguistic intuition to verify mathematical hypotheses, how he built certainty from fragments. The frequency analysis techniques that secure today's internet traffic, the statistical methods that validate encryption systems, the mathematical approaches to code breaking, all evolved from principles Gardner established while working in his windowless Arlington Hall office. He never sought recognition. His colleagues at NSA remembered him as a man who brought lunch in a brown paper bag, who worked through problems methodically on lined notebook paper, who seemed genuinely surprised when his decrypts revealed atomic espionage. He approached cryptography the way he'd approached his doctoral dissertation on Old High German, as a puzzle requiring patience, pattern recognition, and linguistic precision. The Cold War produced dramatic moments that captured public attention: the Berlin airlift, the Cuban Missile Crisis, Reagan at the Brandenburg Gate. But it was won through accumulated intelligence advantages, systematic understanding of adversary capabilities, and the patient work of people like Gardner, who spent decades in classified offices building the knowledge that prevented catastrophe. While Stanislav Petrov's 12-minute decision saved the world from immediate nuclear war, Gardner's 12-year project helped create the intelligence environment that made such moments survivable. His name appears on no monuments. He received no public honors during his lifetime, but the mathematical and linguistic techniques he pioneered between 1943 and 1952 created the cryptanalytic foundations that helped the West navigate 40 years of nuclear standoff without triggering Armageddon. That might be the most consequential invisible victory in human history.